Hi everyone, my name is Dilip and this is the coursework 2 project of machine learning for robotics of course ID PDE 4433, and the title of the project is facial expression recognition, especially for robotics. So I'm very excited to share my FAR prototype. So this prototype is designed to recognize the different facial expressions and respond accordingly using the Arduino microcontroller. So as you all know, FER is an important field of the computer vision which allows the machine to understand the human emotions based on the facial expressions. So it has the many practical applications which I'm going to use in the for robotics. So example, robots can recognize and respond to the human emotions, can be more empathetic and better to equipped to assist the people. And to demonstrate the capability of the prototype, FER prototype, so I have connected I have used a few hardware components to use it, uh, which are like I have used an Arduino microcontroller and a servo motor and a camera module. So the camera module captures the live video of a person's face and sends it to the machine learning model running on the computer. The model analyzes the video stream in the real time and predicts the facial expressions. It predicts the person's facial expressions. The predicted expression is then sent to the Arduino microcontroller, which is then used to control the position of the servo motor, such as let us take an example like if a person is detected being happy, then the servo motor rotates to a specific angle which is at 0 degrees on, or if you can see on I'll be showing the video of this project. If it turns to the left, then the person is being happy, and suppose if the person is detected to be angry and the servo motor rotate to a specific angle like 180 degrees or towards the right side of the motor. Okay, and to accomplish this, have used the OpenCV library. There are OpenCV libraries to detect the frontal face of the person, like has hair cascades, which that is a OpenCV library which is used to detect the frontal face of the person, and have developed a CNN model, deep learning model, to train the facial expressions, which I will be showing it to you in the meantime. And have wrote a script to connect the Python and the computer and the Arduino interface using a PySerial library. Overall, my FAR prototype demonstrates the potential of using the facial expression recognition in the robotics. So I'll be just showing you how this is going to be work. We have to. So I'll be providing a README file to run this particular prototype. I'm just running this prototype. This second, I'm also recording on my mobile phone. Hello, this is the project. Actually, I'm very bad at doing expressions. Whenever I think you can see the camera over here. Whenever I do it in a happy face, as you can see, the servo motor is rotating towards the left. Yes, and whenever I put an angry face, the servo motor rotates to the right side of the motor. So I'm very bad at making expressions. As you can see, the servo motor rotates to the specific angle of this. So I have used the Arduino to control from the Python this, and this is a servo motor which is able to rotate according to the camera feedback to the machine learning model. So it can detect several emotions like neutral face, sad face, fearful face, angry, happy, and total there are seven, and disgust face. So there are total seven emotions which it can detect. So this is the CNN model which I have used, which is the deep learning model which I have used to train the data set, train the model. Different convolution layers and using some dense layers and batch normalization have been trained this network. And I have using different epochs. So basically I have used different epochs. One is the 80 and one is for 50. For the 50 epoch I got 71% accuracy, and for the 80 epochs I got 78% accuracy. So there are two models actually. There are two models, as you can see on the left hand side of the this the emotion model dot h5 and dot json have the 70% accuracy models, and the FER CNN model which is the 71% of the accuracy. To test to test the epoch, have tried using this different accuracy models. So at present I'm using this model, the 78% accuracy model over here, which loads the file and detects using the frontal hair cascade library is going to detect the frontal face of a human being and sends the 48 by 48 pixel to the model to predict the emotion and display it on the screen. So here are the Arduino interface. If the person is angry, then it sends a command of A, and if the person is happy, it sends a command H. If it is neutral, it sends a command N. So for that, so this is the Arduino microcontroller code. Whenever it receives, so it sends this is this basically C++ code. So it's going to loop the system with A, H and N if else statements whenever there is an input on this particular serial. And this is the summary of the CNN. So this is the 78% accuracy of which I got for emotion model. Well, so overall my FER prototype demonstrates the potential of using the facial expression recognition in robotics. So it shows how the robots can be designed to better understand the human emotions and respond in a more natural and intuitive way. So I hope you enjoyed learning about my project and seeing it in action. Thank you. Well, that's it from my end. Thank you. Thanks everyone.